Hey guys, this is the video for area of trapezoids and kites. So we're going to start off with kites because we just did triangles, which is what we're going to use to solve those things. So let's go ahead and we're only going to do two problems in this short video. We're going to start by looking at a kite. So the first thing we need to know about a kite is a kite has a short top and kind of what I call a long bottom. So you can see here that we have a shorter or smaller triangle, and then attached to it we have a longer triangle. So one way to solve it is to solve for what would be the red triangle and then the blue triangle, and then add those two areas together. However, there's another way that we can do it that's a little bit more simple. If we have a kite, we can also decompose. Ooh, that line is ugly. We can decompose it right down the middle, and then you can see we have this makes a line of symmetry, so it shows that these two sides are exactly the same. So we can just find the area of one side, double it, and get the area of the whole entire thing. So let's go ahead and try that out. So this is actually from problem number 9 for Math 6. And we can see here that this length, sorry, it won't let me grab the picture here. There we go. Okay, so we can see that this length is going to be 4.5 centimeters and 6.5 centimeters combined. So if you can't do that in the top of your head, that's okay to write it out. 5 and 5 is 10. 4 and 6 is 10 plus 1 more is 11. So that whole length is 11. Okay, and then we can see here that this height, just this part, is 3 centimeters. And if you look here, this red triangle is what we're actually going to solve. So we have the length, or like the base, and we have the height. So we're going to go ahead and solve that. We have half base times height. And then I'm just going to plug in my values. I have a base of 11 and a height of 3. Okay, so I have 3 times 11 is 33. And then we have half of 33. But what I like to tell you, or I stop here and I'm like, do I really need to take half of 33? Because I'm just going to double that number anyway to find out what the total area is. So I'm actually just going to go boop and find out that my area is actually 33 centimeters squared. Because whatever I would have gotten half here, I would have had to redo it again. I would have had to add another one of those to get the total area. So this one is 33 centimeters squared. Okay, now let's do our trapezoid. The trapezoid, in our curriculum, it tells us, and we could do this if we wanted to, but a trapezoid is made up of 2 triangles and a rectangle. So really what you could do is you could solve for this triangle, double it, and then solve for the rectangle. That's a lot of work to me, especially if we already know that there is a formula that we can use that kind of puts all that information together. So we know the trapezoid formula is the height, which is right here, times the first base, the second base, or I call big base, the bottom base here, and divide that all by 2. Okay, so now that I know what all those parts are, I'm just going to plug in the numbers and solve. So I have area equals my height, 30, and then my little base and bottom base, so the shorter end of the trapezoid and the longer end of the trapezoid. So I have 28 plus 40, and then all of that is going to be divided by 2. Oops, 2. So some of you might want to cancel this out earlier to make 30 more doable, but I like to just follow order of operations and just go step by step. So in order of operations, I'm always going to do what's inside the parentheses first if there's an operator there, and then we'll multiply and then divide. Okay? So we know we have 30 on the outside, 28 plus 40 is 68. And then we're going to multiply 30 times 68. Okay, so we have 0, 0. 3 and 8 is 24. 6 and 3 is 18 plus 2 is 20. And, ooh, sorry, I dropped my pencil there on the screen. So we have 2040 divided by 2. So I know that 2 goes into 20 10 times. And I know that 2 goes into 40 20 times. And voila, there we go. And of course, we need to put our units. Yay! So super doable. So once we can just identify what each of the parts are, we can just plug it in and solve. Okay. All right. Happy math.